Hi, we're glad to introduce our work, PARTE, Part Guided Texturing for 3D Human Reconstruction from a Single Image. Our main goal is to reconstruct 3D human avatar from a single image. To this end, PARTE sequentially reconstructs 3D textureless human, 3D part segmented human, and 3D textured human. The main limitation of existing reconstruction methods is part misalignment. The existing methods often fail to reconstruct human textures that accurately correspond to each human part, such as pants and human arms. This is because of the lack of prior knowledge about human part information during the reconstruction process. To address the part misalignment, our PARTE explicitly leverages 3D human part information as a key guide to reconstruct 3D human textures. In PARTE, there are two core modules, Part Segmenter to predict part information, and Part Texturer to reconstruct corresponding textures. Part Segmenter predicts 3D part segments from a textureless human geometry. Specifically, Part Segmenter performs normal rendering based on the 3D human geometry, and then assigns 3D part labels to the 3D human surface by aggregating 2D part segments of the human normal maps. However, the normal map can be noisy or blurry due to geometric errors in the textureless human geometry. To improve the robustness of segmentation, SegmentNet additionally integrates features from visible regions extracted from the front view image, as shown in the red box. By incorporating the information from the front view image, our part segmenter ensures consistent part segmentation even with an imperfect geometry, enabling accurate 3D part segmentation. As a result, Part Segmenter predicts part consistent and reliable 3D segmentations. These 3D part segments are utilized as key guidance for the next stage, human texturing. Next, Part Texturer module reconstructs 3D human textures from the 3D part segmented human. To infer the human appearance of the invisible regions, we apply the score distillation sampling strategy, based on our proposed part diffusion model. The key design of part diffusion is to ensure alignment across human parts and front view appearances. For effective integration of part information and front view appearance, we adopt an attention process on the separately encoded features, part feature from the part segments, and front feature from the front view image, as shown in the red box. With this design, our part diffusion effectively aggregates part information and frontal information to generate plausible 2D human appearances corresponding to the input image and part segments. Additionally, this figure shows that our proposed part diffusion is capable of generating human images while preserving the appearance of the input image, even when given diverse clothing styles. Here is our ablation study. By using Part Segmenter, we can obtain accurate 3D part segmentation results and help with human texturing to ensure the part alignment. This figure demonstrates that our proposed part diffusion is much more effective in 3D human texturing than other diffusion networks, such as stable diffusion and instant diffusion. As a result, our PARTE accurately reconstructs both 3D part segments and 3D textured humans under in the wild scenarios. Please feel free to enjoy the various reconstruction results from PARTE. Thank you for watching the video. You can find more details about our work by scanning the QR codes.